In video 5 of Unit 1, we're going to take a look at the learning objective in regards to density. So density is a physical property that relates the mass of an object to its volume, or in other words, mass per unit volume. So we're going to define density and specific gravity and use these quantities in mass volume calculations. So the density of a substance compares the mass of an object to its volume. So essentially, density is mass divided by volume. When we're looking at solids and liquids, we can use mass or grams per centimeter cubed or grams per milliliter cubed. Remember that grams are the base unit for mass. Milliliters are not a base unit, it is a prefix unit for the volume. If we're taking a look at the density of gases, it's going to be measured in grams per liter. Note that 1 milliliter is equal to 1 centimeter cubed. If you remember, we mentioned that 1 milliliter is equal to 1 centimeter cubed is equal to 1 cc. How do we take the volume? How do we take the mass of an object? Well, generally, if we have an odd-shaped item, we can get the density by what we call displacement method. So I can take the mass of this object, this is a piece of zinc, I can put it on a balance, and I can get the mass. Notice that the mass of this object is 68.60 grams. How many significant figures are in this value? 4. Which one of these digits is the uncertain digit in this value? The 0, correct. Is that 0 significant? And if so, why? It is because there's a decimal place in this value. So we would take the mass of this substance, we would get a graduated cylinder that has a known volume. We would read this volume, it's 35.5 milliliters, and then we would add that item into the graduated cylinder carefully. Notice that the volume in the graduated cylinder is displaced by adding the substance, and displacement means that it moves out of the way. So the volume increases now to 45.0 milliliters. And why do we have a 0.0 on the end? Because we can guesstimate that number in the first decimal place. We have to maintain its presence by adding a 0 there, even though the measurement is directly on the line. So how do we take the density? Well, we first have to get the volume of the object. The volume is not 35.5 and it's not 45.0. We first have to do some subtraction in order to get the volume of the piece of zinc. So 45.0 minus 35.5 gives us 9.5 milliliters. And notice we keep that 1 decimal place at the end. We can now determine the density of this item by dividing the mass by the volume. Notice that when we do this calculation, we have 4 significant figures in the mass and 2 significant figures in the volume. Our final calculation can only have 2 significant figures. So our answer is 7.2 grams per milliliter. Now, you may be wondering, when we do certain calculations, how do we know which amount to keep in the number of sig figs? You have to consider the calculations that you do first in order, right? Which calculation did you do first? How many significant figures were in that calculation? You carry that over to the last calculation. So we know that the density of substances is going to determine whether they float or whether they sink in other substances. So we have here varied densities. And for most pure substances, the solid phase is the most dense because most substances are going to contract when cooled and expand when heated. Water behaves differently, that when it's cooled, it contracts until it begins to freeze. And once water begins to freeze, it actually starts to expand again. And because of this, ice is less dense than liquid water, which is why it floats on a glass of ice water. If we are to compare the densities of substances, less dense substances will float on the top of a more dense substance. So ice and water substance and other substances with a density less than water will float on top of the water. Any substance with a density higher than the water will sink in the water. And that's what we're looking at here in the density tube. Notice that this substance here is down at the bottom of the tube, and these items that are less dense than water are floating. Notice that the item on the top is less dense than these other two items here. And the item here on the bottom is more dense than the two items above it. So what are some substances that you know of that will sink or float in water? You know plenty of things. Do an experiment. Take a banana and put it in a container of water. Note whether the banana floats or sinks. Peel the banana. What happens when you peel the banana? Does it still float or sink? Tell me. Again, these links here are clickable in the presentation that you have posted on Blackboard. Let's do an example. If you remember here, we have density that is, we can write the value. It is not a measured value, but it's a calculated value. And if you remember from one of the previous videos for Unit 1, we mentioned that anytime you have a unit that can be written in a fraction, that unit can be used as a conversion factor. And when we took the measurement of this zinc, notice that we have grams per milliliter or grams per centimeter. We can use that information to calculate either the volume or the mass given the density. Let's try one of these problems. What volume of isopropyl alcohol would you use if you needed 25.0 grams? The density of isopropyl alcohol is 0.7885 grams per milliliter. One thing to note is when you're using these kinds of, if we're using conversions, never use the conversion factor in determining your total number of significant figures. Always use your measured value. Because if you remember, when we did the calculation for the zinc a little while ago, it was based on the volume and the mass that we measured, and we had to round off. So you never use these type of compound units in order to determine the final number of significant figures. So what do we have? What were we given? We were given that we have 25 grams, and what we need is the volume. We were also given the amount of, we were also given the density. So our given values are 25.0 grams and our density, which is 0.7855 grams per milliliter. And what we need is the volume. So if we start off with our density is mass per volume. And if we rearrange this equation by multiplying both sides by the volume, we end up with mass is equal to the density times volume. And if we divide both sides by density, then we can now get the volume is mass over density. So what does our volume equal? It equals 25.0 grams divided by 0.7855 grams per milliliter. Our grams are going to cancel out. and we end up with 31.8 milliliters. Why do we have three significant figures? Because this is a division problem, and we can't have more significant figures in our calculated value than our measured value with the least number of sig figs. So we've got 2 sig figs here, and our final value has to have 2 sig figs. Again, we don't use our conversion unit to help us determine the number of sig figs. If you go into the nursing field, you might see something called the specific gravity. Specific gravity is the density of a substance divided by the density of water at the same temperature. So at normal temperature or room temperature, the density of water is very close to 1 gram per milliliter. So at normal temperature or room temperature, specific gravity of a substance is numerically equal to its density. However, that may change if we're at a different temperature. Why is this important? So when you go to the doctor's office and you give a urine sample, the specific gravity of the urine is measured to make sure that we have the right number of dissolved solids in urine. So there's something called a hydrometer that is used to measure the specific gravity of that urine. And the hydrometer can be used to measure the specific gravity of any liquid. And so because urine is water that has many dissolved solids in it, we can compare the specific gravity of that urine to water, and it should have a value, it should have a specific indicated value. We won't be doing any calculations with specific gravity in this course, but I wanted to share that information with you for those of you who are going into the medical or nursing field.